Okay. Using fact, for any solid with a uniform cross-section, its volume is equal to its cross-sectional area times its altitude. Okay? And we're looking at the volume of a disk. Now, what I have here is pretty much a disk, although it's a little bit beveled. Okay? So it doesn't have a uniform cross-section. But what do we mean, first of all, by cross-section and altitude? This is cross-sectional area, and this is altitude, right? Well, a cross-section would be if I slice it like this. Okay? And altitude, it's like base times altitude. Okay, but now it's area of the base times altitude, where the base is your cross-section. Okay? And the altitude has to run perpendicular to the base, right? With a parallelogram. Okay? So we really need to understand why all that is true, to understand this as deeply as we really should. However, we can get by just by focusing on what the cross-section of this disk would be, and what the cross-sectional area would be, and what the altitude would be. Okay, in the case of this disk, well, I mean, it's got a radius, which we would here call r, right? And a thickness, delta x, that would be the thickness, right? For this particular disk, I'm saying the radius should be about 10 centimeters, because that's how I designed it, okay? The thickness looks like about 1.7 centimeters. It's actually probably not. Is that 3/4 of an inch or half? Yeah, could be 1.7. So, what is a cross section? Well, in not giving you a general definition, but in the case of this thing, what do we have? We hold the disc flat and slice it, and then hold up that slice. What shape do we see? Okay. Slice this bottle. What's the shape of this slice? Huh? It'd be a circle. Okay, so if we slice this bottle, the shape of the slice would be a circle, right? And if we slice it this way, what's the direction of the altitude? Give you a hint, it's perpendicular to the cross section, right? So what's perpendicular? Yeah, this direction, either this way or this way, whichever way you want to think of the bottle, right? Whichever direction you want to think of positive. Okay? Okay. Now, this is really nothing topologically than a flatter bottle, isn't it? Or a flat cylinder. Okay, because the part of the bottle I sliced was the cylindrical part, so just focus on the fact that's a cylinder, right? Well, so is this. Now, there's a formula for the volume of a cylinder, but we don't want to use that formula, okay? Because it's not going to be very helpful if we have anything besides a circle. But if we have something with a uniform cross-sectional area, it doesn't matter that it's not a circle as long as it's something we can find the area of, right? Okay? Could be a prism, which would be something that has straight lines on the boundaries of its cross-section, okay? Could be elliptical, an elliptical cylinder, you know, wider this way than this way, but uniform going up and down, right? Okay, so what's the altitude of this thing? Well, I just gave it to you, right? What did I say? 1.7 centimeters. You didn't have to remember that, but I'm glad you did. Okay? The altitude would be h, right? Now, what's the shape of the cross-section? Yeah, if you slice this thing, I'm going to get a circle. It's going to be just like this one, right? Okay, because I hold it up in that direction, you see the cross-section. And how do you get the area of a circle? Okay, let's see, 2 pi r. What's the other alternative? Okay, I don't want to put you on the spot because people generally don't remember this. So I'm going to put you on the spot, but off camera, because I don't want to do that on camera, right?